Hello good people, I'm going to talk about areas of composite shapes. Composite shapes are shapes for which we do not have a ready-made formula. However, they can be divided into more regular shapes for which we do have area formulas. The area of the composite shape here can be calculated using a number of different approaches. I invite you to try to solve it yourself before continuing with this video. How did you go? Now, do not mince your words, tell me exactly how you feel. I'm going to divide this composite shape into three regular shapes. This yellow rectangle, this lovely purple rectangle, and the orange triangle on top. Next, I'm going to write the area formulas for these shapes. And now I'm going to substitute. The yellow rectangle is 6 centimeters long and 18 centimeters wide. This gives an area of 108 square centimeters. What about the dimensions of the purple rectangle? This entire base is 15 centimeters long. However, 6 of those 15 centimeters belong to the yellow rectangle, which means the base, or the length of the purple rectangle, is 15 minus 6, and that is 9 centimeters. How wide is the purple rectangle? The width of the entire shape is 18 centimeters, but 12 of those centimeters belong to the orange triangle, which means the width of the purple rectangle is 18 minus 12, and that is 6 centimeters. This means that the area of the purple rectangle is 54 square centimeters. In case of the orange triangle, its height is 12 centimeters, while its base is the same as the length of the purple rectangle, 9 centimeters. And so we will have 9 multiplied by 12 divided by 2. And that will give an area of 54 square centimeters. The total area of this composite shape is all of these areas combined. And that will give me 216 square centimeters. This was not the only way to solve this problem. Rather than dividing this composite shape into these three regular shapes, we could have done this. Now we have a yellow rectangle and a red trapezium. Alternatively, we could have calculated the area of this blue rectangle and then subtracted the area of this white triangle. There are many paths to success, and I know that the mere thought of this makes all of your pleasure centers come alive with excitement. And so, while you are in the mood, let me explore another example. This composite shape might appear a bit tricky, but there are clues that suggest how I should approach it. Firstly, there is this line A, and we are told that that is the epithem. Recall that an epithem is a straight line from a center of a polygon to the middle of one of its sides. Next, it seems as if though I have 3 semicircles, and maybe that is a good place to start. Here they are, colored in green. And now the pentagon springs out. I'm going to write the formulas for these shapes. For the blue pentagon, it is the number of sides multiplied by the side length multiplied by the epithem divided by 2. What should I do for the semicircles? The area for a full circle is pi r squared, but I have semicircles, so I'm going to divide pi r squared by 2. There are 3 of them, and so this entire thing needs to be multiplied by 3. And now I can substitute in for both formulas. This gives the area of the pentagon as 49.06125 square meters. I'm going to round the result to 3 significant figures, and so I will have 49.1 square meters. When it comes to the circle, I need the radius, and the radius happens to be d divided by 2. d is 5.34 meters, so the radius is half of that, 2.67 meters. So let me quickly substitute. When rounded to 3 significant figures, this gives 33.6 square meters. The total area will be the sum of these two areas. And that gives me 82.7 square meters. Now I know that you are keen to do more, but let's stop on this natural high. That is all for now, and I will see you on the flip side.